Okay, so here's a quick video on how to simplify surds. But before we do that, we're just going to dip into what the definition of a surd actually is. And it starts by talking about radicals. So radicals, anything basically, as you can see here, anything with a root sign. Anything with a root sign is a radical expression. Okay, so these have got either second root, in which case we don't write the number 2, because these are the most naturally occurring roots that we use, maybe thanks to Pythagoras' theorem, or there might be third roots, and they could be fourth roots or fifth roots. So all of these numbers are radicals. Okay, radicals. So this is maybe a big family, but from the radical family, split it into 2 different groups. And one group is that if the answer to this radical is a nice number, then we put it into this group here, because the square root of 4 is actually 2, and 2 is a ratio number, a rational number. It's actually 2 over 1, so it can be expressed as a fraction. And so basically we just go through this and we feed in these radicals into the separate groups. Now root 5 is actually 2 point something, and it's going to be not rational, so it can't be written as a fraction. This is a never-ending decimal which doesn't repeat. The third root of 8, well, I think that's 2, right? Because 2 times 2 times 2 gives 8. So that's a nice number, that's a ratio number, a rational number here. And the third root of 7, well, again, if 2 times 2 times 2 is 8, then it's got to be a number just less than 2 to give 7. So that's not going to be a nice number. It's not going to be rational. It's going to be irrational. These last two are a little bit tricks. The second root of a half, well, think of a number times by itself to give a half. Actually, it can't be done. So the answer is maybe something like 0.7123. So this is irrational down here. And this one here, think of a number times by itself to give 1/8. In fact, that is 1/2. A half times a half times a half is 1/8. So if you do a half times a half times a half, you can see that gives 1 over 8 times the top times the bottom. All right, so that's how to split radicals into rational numbers or irrational numbers. And then finally, we get the definition of a surd, because a surd is definitely a radical. It's got a root sign written, but once you play with the root sign, if it simplifies to a rational number, then it's not a surd. Surds are these guys down here. So surds are numbers with roots that don't simplify. They're irrational radicals. So we could write that down actually. Surds equal irrational radicals. All right, so let's move on to using this beautiful rule, which I know many of you discovered in an investigation. So we can write it this way, or we can write it this way. And I've tried to write out in words to develop our language. So let's see. The root of the product. Well, a product is a multiplication. So the root here of the product is equal to the product of the roots. Okay, so we can split up a multiplication. So any multiplication that's under a root sign, we can split it up and do the individual roots and multiply the answers together. So that could be quite useful to us. All right, so let's see it in action. So down here, we can split 50 up into 2 numbers that multiply together. Now I'm going to choose nice numbers, because when we split this up, you can see what happens. This becomes 5 root 2. And over here, I'm also going to choose some nice numbers. And I'll tell you the trick of how I'm choosing those nice numbers. Now, the trick I was choosing was within the product, I was choosing a square number. And more than that, I was choosing the highest possible square number. So square number here, but I was choosing the highest square number. Now, if you don't choose the highest square number, you can still get there, but it makes it a little bit harder.